Hello everyone. In this video, let us see refraction from rarer to denser medium at a convex spherical refracting surface. Let a spherical refracting surface xy separates a rarer medium of refractive index μ1 from a denser medium of refractive index μ2. Suppose the surface is convex towards rarer medium side. Let P be the pole, C be the center of curvature, and R radius of curvature, which is the distance from pole to center of curvature of the surface. Consider a point object O lying on principal axis of the surface. A ray of light starting from O and incident normally on the surface XY along OP passes straight. Another ray of light incident on XY along OA at an angle of incidence I is refracted along AI at an angle R, which is angle of refraction. Here the light ray after refraction bends towards the normal. The two refracted rays meet at I, which is the real image of a point object O. From A, draw AM, which is perpendicular to OI. Let angle AOM is equals to alpha, comma, angle AIM is equals to beta, and angle ACM is equals to gamma. As external angle of a triangle is equal to sum of internal opposite angles. Therefore, in triangle IAC, here it is I and this is A and this is C. The exterior angle is here gamma. Interior opposite angles are R and beta. So I can write gamma is equals to R plus beta. If we take R subject, then we can write it as R is equals to gamma minus beta. Okay, let us take similarly another triangle OAC. Okay, in this I is exterior angle, alpha and gamma are opposite internal angles. Okay, so triangle similarly in triangle OAC, I is equals to alpha plus gamma. Okay, let us apply Snell's law. According to Snell's law, mu2 upon mu1 is equals to sine I upon sine R. Here the angles alpha, beta, gamma are small. So sine I can be written as I and sine R can be written as R. That is I upon R. since angles are small. Okay, so from this I can write mu2 r is equals to mu1 I. Let us multiply mu2 with r and mu1 with I, cross multiplication. So I can write it as mu1 I is equals to mu2 r. Okay, so now here I is what? Alpha plus gamma. R is what? Gamma minus beta. So I can write it as mu1 into alpha plus gamma is equals to mu2 into gamma minus beta. Okay, in the ray diagram we can consider three right angle triangles. Okay, first right angle triangle is OAM. In this right angle triangle, angle is alpha here. Second right angle triangle AMC, and third right angle triangle AM and I. For AMC, gamma is the angle. For AMI, beta is the angle. Let us take tan alpha, tan beta and tan gamma. We know the definition of tan is opposite side by adjacent side. So let us write tan alpha, tan beta and tan gamma. So first tan alpha. Tan alpha is equals to, from the triangle OAM, angle is here alpha, opposite side is AM, opposite side by AM by adjacent side. Okay, adjacent side is what? MO. MO. In the same way, let us write tan beta and tan gamma. So tan gamma, let us write tan gamma is equals to, in this AMC, gamma is the angle here, opposite side is AM, adjacent side is MC. So I can write it as AM upon MC. Then tan beta. Tan beta is equals to, the right angle triangle is AMI and angle is at I, opposite side is AM, adjacent side is MI. So I can write it as AM upon MI. As we have considered it as angles are small, tan alpha can be written as alpha, tan beta can be written as beta, and tan gamma can be written as gamma. And let us substitute these alpha, beta, gamma terms in the expression 1. Let us consider this as expression 1 and let us substitute this alpha, beta, gamma in this expression 1. As angles are small, alpha is equals to AM upon MO, comma, beta is equals to AM upon MI, and gamma is equals to AM upon MC. Let us substitute this alpha, beta, gamma in expression 1. Then we can write this as mu1 into alpha is AM upon MO, gamma is plus AM upon MC is equals to mu2 into gamma is AM upon MC minus beta is AM upon MI. Okay, as aperture of spherical surface is small, as aperture of spherical surface is small, M is close to P, M is close to P. Here P is what? Pole. In the ray diagram, you can see in the beginning we have drawn a perpendicular from A to M. As the aperture is small, this M is close to P, so M coincides with P. So we can write as M is close to P, therefore MO can be written as PO, and MI is equals to PI, and MC is equals to PC. If we substitute these terms in the above expression, then we can write this as, and if we take AM common on both the sides and if we cancel it, then mu1 into 1 by MO is nothing but here PO plus 1 by MC is nothing but PC is equals to mu2 into AM. As AM got cancelled, I can write 1 upon MC is nothing but PC minus MI is nothing but PI, 1 upon PI. Okay, so let's multiply with mu1 the terms. I can write it as mu1 into 1, mu1 upon PO plus mu1 upon PC is equals to mu2 upon PC minus mu2 upon PI. Okay, let us write PC terms at one side and let me transpose this minus term to the other side. Then I can write this as mu1 upon PO plus mu2 upon PI is equals to mu2 upon PC minus mu1 upon PC. Let us take PC common in this. Okay, so then we can write this as mu2 minus mu1 upon PC. So here I can write it as mu1 upon PO plus mu2 upon PI is equals to mu2 minus mu1 upon PC. Okay, now let us use sine conventions. Using sine conventions, okay, we put PO. What is this PO? Object distance. That is equals to, object distance is negative because as measurements are done opposite to the direction of incident rays are negative, comma, PI is what? Image distance. That is equals to plus V, and PC is equals to radius of curvature, that is plus R, because V and R are measured to the direction of incident rays from pole, so they are positive and object distance is negative. When I substitute these terms, right, then we can write it as mu1 upon minus U plus mu2 upon V is equals to mu2 minus mu1 upon R. So if we rewrite these terms by taking first positive term, then I can write this as mu2 upon V minus mu1 upon U is equals to mu2 minus mu1 upon R. Here mu1 and mu2 are refractive indices of rarer and denser medium. V is image distance, U is object distance, and R is radius of curvature. So this is the relation for refraction from rarer to denser medium at a convex spherical refracting surface. Hope you have understood the derivation, that is mu2 upon V minus mu1 upon U is equals to mu2 minus mu1 upon R. Thank you.